Hi, I am your mystery guest. My name is Dee. I work for digital infrastructure at the Royal Netherlands Academy of Arts and Sciences, Humanities Cluster. Like them, I'm interested in history, language, art, data, technology and how all these things come together. Let me tell you a little bit about us and what we do. The Humanities Cluster is the result of merging the IT teams from 3 institutes. We've already built a lot of tools for research. Most of these are web applications that do not yet really work together. Our primary aim now is to connect them. We want to help researchers make data selections that can be analyzed by chains of language and image software, extracting information and enriching the original sources. The results are then returned to scientists for further human analysis. Building these connections is what turns software into infrastructure. The magic word for that is open standards. And yes, that is actually 2 words. This will allow us to combine data from entirely different areas. We want to allow you to connect historical sources with other scientific fields such as archaeology and medicine, but also with cultural heritage, governments, and corporations. Moreover, we wish to open up humanities research for use by others. Think, for example, about the media, policymakers, teachers, and journalists. Researchers want to work with collections beyond the walls of their institute. They need to be able to analyze data from all over the Netherlands, from Europe, and actually across the globe. To enable their research, we separate archive and research infrastructures. Archive infrastructure needs to be sustainable and expose only carefully curated data. Research infrastructure, on the other hand, is volatile. It is dynamic and subject to change. It must be able to handle data that is not cleaned or carefully selected. It needs to be open for experimentation. Let's take a closer look at research infrastructure. We distinguish 3 data streams. The first handles the digital representation of reality. It contains images, audio, and video. Image software, for example, can extract text, detect faces, analyze in color, or identify typewriters. The second stream continues where the first one stops. It handles transcribed reality. It works not only with manually transcribed sources, but more and more with automatically generated texts. Through optical character recognition, handwritten text analyses, or speech-to-text audio processing. With a transcription of varying quality available, we can start extracting linguistic elements, such as nouns, verbs, and sentence structure, as well as detect names of people, places, objects, and dates. Detecting that a combination of letters is a noun, and likely the name of a person, is only half the job. To make sense, we need to know who the name actually belongs to. To do that, we come to the third and final data stream, structured data. This is the semantic representation of reality. Large graphs of identified people, with birth date and location, and many other characteristics. We add these records to locations, objects, and events that were collected over centuries of research. Combined, they form knowledge graphs and explain how people are connected, where they worked, lived, and traveled. A process called disambiguation identifies the name that was recognized in a transcription. It links the occurrence in a text to the known person in the knowledge graph and makes the entire context available to the researcher. Through this process, we are capable of working with 17th century shipping records, identify the sailors on board, and follow their careers. We can follow the voyages of individual ships, books, goods, texts, and even ideas, and see where they were at different moments through the ages. Don't believe us? We'll show you. In products such as NaturLab and Pergamon, we want to make every text available to a wide audience of researchers, teachers, students, and the general public. We offer platforms that place sources in their original context. These tools bring together texts from many different authors and institutions across time and space. They add the ability to analyze them over a long period of time, combine them with contemporary texts and in the original language. We call these virtual collections. NaturLab has specific features to support these virtual collections. The platform aids the user in their search and holds into account how context is different in different eras. For example, through a method we call lexical query expansion. When the user enters a search term, the software knows that it needs to search for different words in different periods. The system helps the user in formulating a question by linking modern, early modern, and medieval Dutch dictionaries in a network of words. Triado is one of those projects in which a lot of technology comes together. The project is funded by the Academy's Research Fund and aims to automate closed research access to the archives of the Dutch tribunals prosecuting crimes committed in the country during World War II. Together with the National Archives and the Dutch Institute for War, Holocaust, and Genocide Studies, we are digitizing 13 meters of dossiers as a pilot sample. The scans are then processed in a pipeline of image tolling that classifies documents and generates text. This transcription is handed over to language software that recognizes war criminals, partisans, witnesses, and victims, and connects them to existing databanks. Finally, we would like to show you HuC. The tool allows you to come as close as possible to actual time travel. Sounds exciting? Let me show you. We extract information from sources and find occurrences of people, places, and events. We link them to known data. Such networks are called knowledge graphs, and these also allow people to do research over time and space. HuC brings these two dimensions together. As an example, we have taken the travels of the Dutch seafarer Abel Tasman. In the first half of the 17th century, he was sent out twice in search of the mysterious land known as Terra Australis. From his logs, we extracted his location to link data and mapped his first trip. Now you can actually see where he went. If there was a medal for not finding Australia, Tasman would probably have won it. When looking at his journey, we cannot stop thinking, how can you miss it? At least he did manage to discover Tasmania, the island that still carries his name. On his second trip, he eventually discovered Australia and explored large sections of the continent's northern coast. These are just a couple of examples, and we are working hard to make all of our tools compatible with all the data stored in our repositories. This allows you to analyze text, extract information, and follow the migration of people, objects, and ideas in any period you want. There's a lot for us to do, but we think it's fantastic to have the opportunity to bring the humanities and sciences together. We are convinced that the future of the humanities is in solid data-driven science. Connected software systems are crucial for that. Now we're taking the next step, away from making the humanities more digital and towards making the computational sciences more humanist.